Hello, the lecture today is about the drugs effect on the blood pressure, arterial pressure, and we are going to study this topic in two parts. In our, practical classes, but the lecture will be only one. So the hypertension, essential hypertension, is also called. It's a disease caused by a variety of heterogeneous factors, which is based on a genetic polygenic structural defect that causes high activity of pressure mechanisms of long-term action. Well, actually, it is considered to be based on genetic structural defect, but nobody is sure about that. What are the primary reasons of the hypertension? Still, we don't know. Well, what are the parameters of the blood pressure? The optimal blood pressure should be less than 120 to 80 millimeters. How to say less or equal. Then you can see the normal blood pressure is also up to 130 systolic and 85 diastolic, and the rest are already increased. So they increase their hypertension grade 1, hypertension disease of second degree and third. So what are the factors which determine the level of blood pressure? They are of several types. The first is hemodynamics, the cardiac output. The more is the cardiac output, the bigger is blood pressure. Total vascular resistance, this is how much the blood vessels can contract against the pressure of the blood on them. And the rheological properties of blood. If the blood is more liquid, so we have less blood pressure. Okay, these all are on the organ level of regulation of blood pressure. Also, we have the system level of regulation of blood pressure. So the system which are first pressure systems, sympathetic nervous system, and renin, angiotensin, aldosterone system. So sympathetic nervous system, we remember that this is a part of vegetative nervous system, yes, which activates in the case of stress. When we have high stress level, we have the activation of sympathetic nervous system, and by that our blood pressure increases. Renin, angiotensin, aldosterone system is the system of the enzymes which circulate in the blood, and they are also responsible for the constriction of the blood vessels. Depressor systems, which are reducing the blood pressure, are kallikrein-kinin system with the bradykinin enzyme, not enzyme, like signal molecule. Okay, and prostaglandins, which we know from the previous topics. So also we have the myogenic factor. Myogenic factor is the concentration of calcium ions in the cell. So what do we know about the calcium? If this picture shows us the intracellular process in the smooth muscle. Sorry, intracellular process of the smooth muscle. So what do we see here? Smooth muscle. What do we see here? We see that we have the deposition of calcium in this tubule, in the T system of the intracellular space. This is the part of endoplasmic reticulum, and we can see that there is a chain of actin protein and myosin, which should bind to the actin to make a contraction. But here, in the absence of calcium ion, we have troponin with the chain of tropomyosin, which blocks the connection between actin and myosin. So you see, they are it's impossible for them to bind to each other. So when we have the release of calcium, when we have the high level of calcium in the cell, This calcium binds to troponin and removes tropomyosin from the actin and myosin connection. So they can connect and they can make a movement to contract the muscle. Okay, so we can see that finally presence of calcium ions helps in contraction of the muscle, because muscle can contract only when actin and myosin bind together. Okay. The variance of pharmacological correction of blood pressure. First, what we can do is to weaken the activity of the sympathetic nervous system. Of course, if the sympathetic nervous system with activation stimulates the contraction of our vessels, stimulates the work of heart, so the weakening of this activity would block our high blood pressure. Inhibiting the renin-angiotensin-aldosterone system, of course, the same. Less enzymes in the blood, which are responsible for contraction of the blood vessels, so less blood pressure, and reduce the concentration of calcium in vascular muscle cells. This is already a direct effect on the muscle cells. Less calcium, less actin myosin connection, less contraction of the muscle. So we will start with the first type of effect, the weakening of the activity of sympathetic nervous system. So what do we see in the structure of sympathetic nervous system? Everything starts with the CNS, the central part. Yes, the central part in the CNS is actually the vasomotor center, our favorite vasomotor center. Okay, the vasomotor center, when it is activated, it sends the sympathetic impulse through the nerves. Yes, this is the nerve. Okay, the preganglionic nerve then connects with the postganglionic nerve and forms the ganglion. In the ganglion, we have N-cholinereceptors, which switch the signal, yes, from the preganglionic nerve to the postganglionic nerve. Okay, so this is the ganglion. And then from in the postganglionic nerve, the impulse goes directly to the effector cells. So if this is the blood vessel, it would be alpha receptors. If this is heart, it will be beta receptors, for example, or any other organs in which we have alpha and beta adrenal receptors. So guys, please pay attention that preganglionic nerve has acetylcholine mediator and releases the signal through the N-cholinereceptor activation, because acetylcholine we have in this synapse. And in the second neuron, we have noradrenaline, because here we have adrenal receptors. Okay, remember this came from our nervous system. Okay, so what happens when all these parts are activated? It sends the central nervous system sends the impulse to all the organs which have innervation with sympathetic nervous system. Here you can see the effect which sympathetic nervous system does to our body.